This conference will now be recorded.
Yeah, welcome back, guys. Yeah, in last video we discussed about partition. So some introduction about the partition. Now we'll talk in detail about how the partitions will be divided. This is a $1,000,000 question, guys, because I have seen, every session I give, there will be a lot of people asking how these partitions will be created. I'm reading data from file system, local file system, or normal file system, how the partitions will be created. I'm reading data from HDFS, how the partitions will be created. What is this? So we'll talk about that. And before that, again, a little recap. So what is a partition? Partition is a logical representation of piece of data or logical division of data which will be processed by single task. Actually, this idea came from MapReduce, as I said in the last. In the MapReduce, we have something called input splits. What is input split? Input split is input split. Input split is logical representation of piece of data which will be processed by single mapper. So if you have a big data or a huge amount of the data cannot fit into one memory or one disk, because if I want to better performance or if I want to parallel process, the data has to be distributed across the multiple machine. The data has to be processed parallelly and the different machines. To do that, the data has to be splitted into pieces. Each split be each split will be processed by one task. So similarly, the previous example or previous video, we have created one RDD. When we created the RDD, it is a collection of partitions it created. How the collection of partitions are created, that's what we're going to see now. Okay, so why partitions should be created? Very simple, to get the parallel process. If I get the parallel process, I'll get the better performance, and the data has to be distributed across the multiple machines. The data has to process in the multiple machines. So for that reason, we need a parallel process. Okay, here there is a configuration also, spark.default parallelism. Okay, default partitions, I mean to say. So that also I'll show you. Before that, just go ahead and create a partition. How the partitions will be created? Go ahead and create a RDD, then we'll see how the partition will be created. So there are different ways to create an RDD. So we'll see those different ways. Okay. The first way is, let me take a brush window. So I'm going to create an RDD from the collection of data. From the collection of data, let's say val data equal to, I'm going to keep an array of data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can use 1 to 20 also. So there is an option too. We can, instead of typing each and everything, I can use 1 to 20 also. Now I have created collection. When I say array, it's a collection. Array of integers, it's a collection, right? I'm going to create a RDD. To create an RDD, as I said, we have a multiple ways. One of the way is creating RDD from the Spark context. sc dot parallelize. You can use a parallelize method by passing data collection of data. I'm not going to specify any manual partitions here. I want to decide my system to recognize how many partitions has to be there. My Spark has to recognize how many partitions RDD has been created. Now, this data, as I said, this data is distributed across the multiple partitions. I mean, I divided into multiple partitions. Let's see how many partitions has been divided. To know that how many partitions has been divided, we can use get num partitions. Get num partitions. You can just type a few dot, after dot you just type 3-4 letters and press tab. If the method is existing that object, it will be automatically completed. So I have 8 partitions. So how come 8 partitions you get here? How come 8 partitions I get here? Okay, so you said that it is 8 partitions. How the data is distributed into 8 partitions? how this data is distributed into 8 partitions. Let's see that also. RDD dot gloom dot collect. There is something called gloom. We can use the gloom to see the data partition wise. Look at here. Look at here. This is the data. As I said earlier, RDD is a collection of data. When I say collection, it is a collection. Look at here. It is what it is. It is a array. When I say array, it's a collection of data. Nothing but collection of partitions. Each partition will have a data. Each partition will have a data. This is collection of partitions. Array is a outer array is your RDD, inner array is your partitions. Okay, let's see this one. Copy this. Let's go to Notepad. I'll just go to Notepad. Paste here. Okay. First partition, second partition, third partition, fourth, fifth, sixth, seventh, eighth partition. These are 8 partitions. These are 8 partitions. Now the question, how it is divided into 8 partitions? If you are using parallelized method, and creating an RDD from the collection, how many cores are there in your machine? Wherever your shell is running, how many cores are there in machine? Those many partitions will be created. My machine is i7, so I have 8 partitions. My machine is i7. It created 8 partitions. Okay. Next. Let's say I can control my partitions while creating a data. While creating RDD, not the data, sorry. While creating RDD, I can control my partitions. How? Let's go ahead. Here you have an option how many partitions you want. If I say 4, it will come in 4. If I say 3, it will come in 3. Let's see. RDD. You can say number of partitions, 3. You can see gloom.collect. You'll see 3 arrays. 1, 2, 3. One is you can control, other one is automatically it creates based on the number of cores available in your system. Next, other way of creating it. Other way of creating it is based on your system number of cores. How many number of cores are other way of creating is with a text file. Okay. Other way of creating is RDDs with the help of the Spark context.text file API will use. Or if you already have RDD, we can create another RDD from it by applying the transformation. Or there is one more method called make RDD. There is something called make RDD. Okay, there is something called empty RDD also. We will see all those things. Okay, let's see. I'm going to create a data from RDD from specified data. Let's see that. Okay, so first let's take the data. So I have some data here and there. Drive data. Should I have a drive data here? Let me pause a video.
This conference will now be recorded.
Yeah, look at here. So this is the file I was searching for it. I got this file with the help of here. I already have executed earlier. So I'm loading a bigger file. RDD equal to sc.text file. Then I'm loading this file. Let's load this file. Okay. Now let's look at how many partitions. RDD.get num partitions. 9 partitions. Okay, it means it gone beyond my system size. Let's look at but if you do the glue.collect, since it is a huge data, there will be huge amount of the data for every partition. Okay, there will be huge amount of data for every partition, but it will show only some part in the console. It will not show whole thing. Okay, it's a little bigger file. So by the time it executes, let me see the size of the file. So I click properties, 261 MB, 261 MB. So it created 9 partitions by 200 and let's calculate how it is get created. Okay, so here 261 divided by 9, it comes 22 MB. But here what we need to understand, not 22 MB, it's not 22 MB. Actually, if you use the text file, and you are reading from the local file system, it will divide by 32 MB. It will divide by 32 MB. If you are using the text file and reading from the local file system, it will consider 32 MB. Let's see that. 261 divided by 32. 8.156. So whenever we say partitions, there won't be points. So 8 partitions plus 0.15 MB file, another partition. So 9 partitions. It means if you load the data from the local file system into the Spark using the sc.txt file, the partition size will be 32 MB by default. 32 MB by default. If you use the parallelize method, how many cores are there in your machine? Those many. If you read from the text file, how many blocks are there? For 32 MB blocks are there, those many partitions will be created. Let's go here. Yeah, it is end up I think it might have thrown the memory issue. Okay, but it is clear, right? So I'll actually exited also. It is stopped. Okay, it stopped. Now we are very much clear. Let me show this as a configuration. So let me show from the configuration. I have some already the configurations here. Default dot parallelism. Look at here, guys. Spark dot default dot parallelism. Okay, the default number of partitions in RDD written by transformations like join, reduce by key, and parallelize will not set by user. Okay, but here look at here. For distributed shuffle operations like reduce by key and join, the large number of operations in the partitions in the parent RDD. So whatever the parent RDD has a more number, so that partitions will be considered. For parallelize method, for operations like a parallelize with no parent RDDs, it depends on the cluster. If it depends on the cluster, if it is a local, whenever you start a Spark shell, it is a local only. Okay, number of cores on local machine. If it is local, your cluster manager is local through parallelize method, or whenever you do the parallelize method, it means you will be reading from the Spark shell. If you read it in the cluster mode, that's a different way. If you're reading in the Spark Spark shell, your number of cores. If you are using mesos, that will be 8, but I haven't tried mesos. I don't know how it will work there. But if you go with the other cluster managers like yarn, total number of cores on all the executor nodes are 2. Total number of cores on all the executor nodes are 2. So it means that whichever is larger. Okay, whichever is larger. Suppose whichever is larger, that will be taken. So that's the reason when you try to read a small file from the local file system, it will create 2 partitions. Okay, so let me show you an example. I think I do have data for word count. Yeah, so let me load this one. File rdd1 dot get num partitions. It's a very small file. Let me show you data for word counts. It's a very small file. Data for word count. So 5 KB, yeah? So close to that much only. 4.9 KB. Okay, so it will take 2. So what I'm trying to explain here is, if you are using the Spark shell, and if you're using not Spark shell, forget about the Spark shell or not. If you're using the local, your master is the local, how many cores are there? Those many partitions will be created. If you're using a mesos or some other, based on the number of cores available in the executors, it will be loaded. So why I'm trying to say parallelize method and all, because we will be launching the Spark shell. In the Spark shell by default will be launching in the local mode only. That's the reason. If you use in a different mode, that's a different story. Let's see how it will work with a programmatic way, not the Spark shell. I'm going to create how it is. Okay, let's take a simple program. I'm going to use a Scala here for this. Let's say, yeah, let me give this number default num partitions demo. I'm going to create an object. Okay, what's this? Okay, let's take a main method. It should come automatically. That's the reason I just typed mine. Okay, so when you create this, obviously we'll create a Spark session. The Spark session is your entry point to a Spark, right? Okay, Spark equal to Spark session. The Spark session will be there in the org.apache.spark.sql.Spark session. It will be there in the SQL package. Okay, so we have to build it. So actually it is not recognized. That's the reason showing the red color. Let me get it automatically. Import it. I told you that org.apache.spark.sql, then there is dot builder. Since it uses the builder pattern, so that's the reason we are building it. You can set the application name. Let me use the tab here. Dot app name. I'm just giving the partitions demo. So, dot sorry, it's indentation problem. Master. I'm going to use a local master. Okay, that's we need to understand. Local. I'm going to give a star for now. Okay. Dot um, get or create. I'm not going to enable that other stuff. I'm not going to give the configurations and all. So I'm just going to create it. So I have created Spark session. Okay. After creating a Spark session, I'll also create a Spark context. SC equal to, because we become familiar with the Spark context, so we'll create a Spark context. So Spark context I have created here. Now since I have used local, right? So let's try creating the same RDD with the data, because I want the data. So I don't want to type everything here again and again. Data val parallelize RDD equal to c dot parallelize. What's happening? C dot parallelize pass the data here. Pass the data here. After passing the data, we'll just print the number of partitions. Okay, I'll just print the number of partitions. So println number of partitions, number of partitions, number of partitions. Parallelize parallelize dot get partitions, get number partitions. So just I'm go ahead and run this program. It will take time, even though it's a small program. Eight, because I have a 8 cores in my system. If I specify 3 here, if I go ahead and run it, I think now it will be faster. Don't take that much time. Okay, 3. Okay, now same, let me read from the file system because I'm using local. Let's see, same thing what I will do. I'll try to read from the file. I'll try to read from the file. This is very small file, guys. Partitions, text file API. Here, it's a very small file which we need to look at here. And this one. I'll take bigger file also. By the time it runs, I'll just copy it. Number of partitions are 2. Now let's go ahead and create a bigger file. Okay, so now let's do the same. I will say it's a bigger RDD, a bigger file RDD, bigger file RDD. Let's see the number of partitions for text file API, bigger file RDD. Just put the bigger file RDD. Just go ahead and run it. So as for the Spark configuration, default configuration, since we are running in the local mode, so the since we are running in the local mode, if you are reading using the parallelize, if you're using the parallelize, how many cores are available? Those many partitions will be created. If I'm using the text file API, since the file size is bigger, I'm reading from the local file system. My file size is bigger, so it will consider 32 MB is the block size. 32 MB is the block size. Okay, so if I'm using Mesos, that will vary. If I'm using Yarn, that will be vary. Suppose if I'm reading data from the HDFS, your block size will be considered as your partition size. Suppose if I have a 1 GB block, 1 GB data in the Hadoop, if I start read the data from the HDFS, how many blocks are there? Those many partitions will be created. Okay, let's do another example. Okay, you are loading the data and creating the partitions. If I create empty RDD, first question, can I create empty RDD? Can I create empty RDD? Yes, we can create an empty RDD. We can create an empty RDD. Let me show you that method. Okay, so where empty RDD 1 equal to empty RDD 1 equal to sc dot empty RDD. Look at that. You have a empty RDD you can create. You can create empty RDD. Okay, try to print number of partitions for the empty RDD. How many partitions will get for the empty RDD? Let's look at this. This is not a parallelize. It is it is empty RDD method. It's not text API. It's a empty RDD API. I don't need to specify this. Let's go ahead and run. How many partitions for empty tab? So to get rid of all the log information, what I can do here is set log level, set error. Empty RDD, zero partitions. Okay, empty RDD, 0 partitions. Okay, so you can also create data type specific RDD. So data type specific RDD also you can create. Let me show you. Here what I will say, int empty RDD, empty int RDD, I'll say int RDD, empty int RDD. So for our segregation, let's specify this. We will get rid of all this info log. Oh, still it is there. Okay, yeah, you can see here empty RDD also. Integer, if you take integer RDD also, it's a 0. It's a 0 partitions. Okay, next, try with the parallelize method. Try with the parallelize method. Okay, so with the parallelize method also we can create empty RDD, but for that we have to pass empty collection. For that we have to pass empty collection. Otherwise, how we can create parallelize method is works based on the collection, right? So we have to pass empty collection for that. Let's take an example. Where empty parallel RDD equal to sc dot parallelize. Here we have to pass collection. That's what I'm trying to say. We have to pass a collection here. So that collection, we have to pass empty collection. So in Scala, the collections are from the sequence, right? There is a sequence class. Okay, there is something called sequence class. From the sequence, we will create a empty. Let's create a empty integers. Create a integers because we are taking the collection of integer numbers. Let's try with the integers. Now here, let's look for the partitions. Let's look for the number of partitions. This is Yeah, empty RDD with the parallelize. I don't need to specify this. I'll just remove. I'll specify here for clarity. Look at this. Yeah. Y3. How many your local you have specified here? 3. If I specify 5, it will come as 5. If I specify 5 there, it will give me 5. Okay. So we have 5 because it's taken based on the number of cores you have specified in the master. See, the master specifies as local. When you say local, it means that how many cores are there you make use. If you say star, make use of all the cores. If you specify the number, those many cores will be made use. Okay. So this is how we'll create empty RDDs. Yeah, not only single RDDs, we can also create a collection. What I can say, like pair RDDs. We can also create a pair RDDs. Okay. Now another question you may get. Yeah, that we'll see in the next video. So let's see with the pair RDD how we can. So again here for the pair you have to create a pair collection. Again pair you have to create a pair collection. Okay. So like a tuple you have to create. Like a tuple you have to create. Let's say ID name tuple. ID name tuple. Take here 01 comma spark 01 comma spark. Here what we will do, we'll just create pair RDD. Pair RDD c dot parallelize. Try with the parallelize. I don't think it will work, but we will do. It will not take. It has to be collection, not the. It has to be collection, not the tuple. So then what we can do directly, you can pass empty. You can pass empty RDD method whenever we have, right there. We can pass this data type. Then it has to be. Then it has to be. Then it has to be type. It is. It no need to be the variable. It has to be type. It has to be type. So it's type ID name. Right? Okay. Sorry. Specify this one is wrong. It has to be when I specify the type ID name. First one is integer. Second one is a string. So it has to be type. Change this. It also has to be changed. But this is not cannot resolve symbol ID name. I have to give like this, right? ID name. Yeah. Let's run this program. Let's see. Okay. We do get 0. This is sc dot empty RDD. It is not parallelized. That's the reason 0. Even if you see in the above, they're all 0. They all in the same category. We're doing SC dot empty RDD. So this is SC dot parallelize. So that's the reason I started with the curly brace parenthesis, but it didn't work. So we tried with this option. Okay. So that's it in this video. So we'll connect in the next video and we'll see what is the Spark context and what is the Spark session. We'll discuss it. Thank you.